Hi everybody, Ms. Lee here. Today we're going to be talking about trig derivatives. So I'm just going to go over the rules of each of the derivatives of the trigonometric functions. So we'll start with sine of x. So remember d dx of sine of x means the derivative of sine of x. So when we write this d dx and then in the brackets, that means that we're taking the derivative of what's inside the brackets. So the derivative of sine of x, that would be cosine of x. And now the derivative of cosine of x, that's negative sine of x. And the derivative of tangent of x is secant squared of x. The derivative of secant of x is secant of x tangent of x. So that means they're being multiplied. The derivative of cosecant of x is going to be negative cosecant of x times cotangent of x. And the derivative of cotangent of x is going to be negative cosecant squared. 6 trig rules. So if you want to pause the video right now to go ahead and make sure you have it all written down, that'd be a good idea. If not, we're going to go ahead and start using them. Okay, so let's go ahead and do an example problem. Okay, so we're going to go ahead and find the derivative of y equals x squared over tangent of x. So as you guys know, when there is some sort of fraction or some sort of division going on there, you have to use what rule? That would be the quotient rule, exactly. You have to recognize, first of all, the first thing you should be doing is identifying what operation is going on in the problem. So we want to identify which rule to use. And of course, since this is a fraction, we're going to go ahead and use the quotient rule. Okay, do you remember the mnemonic for the quotient rule? Well, if you don't, it always starts with low. So low, d high. So low would be tangent of x. D high would be the derivative of x squared. The derivative of x squared, we use the power rule. And so it'd be like 2x and then to like the 1 power. But of course, we don't typically write that one. And then minus, and then high, which is x squared. D low, which is the derivative of tangent of x. That's secant squared of x. All over low, which is tangent of x squared. Okay, so just to reiterate, this x squared was the high, that's right here, and this is d high over here. And low was here, and then d low was over here, and this is also low. Okay, and so just to rewrite this in a form that more people would find conventional, we would say dy dx, or another way to say dy dx is y prime, equals, and then we have tangent of x times 2x minus x squared times secant squared of x all over tangent squared of x. Okay, so remember with trig functions, we write the square or the exponent on the actual trig function. And as you guys know, in my class, we do not need to simplify, so we can leave it just like that. Okay. All right, let's go ahead and do one more example. Okay, so the example we're going to do is finding dy dx given that y equals secant of x plus 3 and then times x cubed minus cosine of x. So first of all, you want to identify what rule we're using. And if you look at here, the biggest operation, so look at the biggest operation. That would be something times something. That means that the biggest operation is multiplication. So what rule should we be using? Well, of course, that's the product rule. So product is when there's a multiplication or the result of multiplication. So product rule is what we'll go ahead and use. So if you remember correctly, that would be for something with u times v, that would be u prime times v, and then plus u times v prime. Okay, so we'll go ahead and identify each of these parts as u and v. So we'll just say that this first entirety is going to be u, and the second entirety is going to be v. Okay, so this is u. This is going to be v. Okay, so for u prime, that would be the derivative of this. The derivative of this is going to be the derivative of each part because this is addition. So when you do addition, we're going to just take the derivative of each part separately. So what's the derivative of secant of x? Well, that would be secant of x times tangent of x. Okay, plus what's the derivative of 3? Well, that's a constant. So the derivative of 3 would be 0. And so we put plus 0. So that was the derivative of u, so we'll underline that. Okay, and then v, you leave that as is. So we write x cubed minus cosine of x, and then plus, and then it says u. So then we write u as is. Okay, so u would be just secant of x plus 3. Secant of x plus 3. And then we do v prime. So v prime would be the derivative of this v right here. So then since there's a subtraction sign, we can go ahead and take the derivative of each part separately, So we'll go ahead and take the derivative of x cubed. Again, using the power rule, we'll go ahead and bring down the 3. So we have 3 and then x to the power of 3 minus 1. And then minus, well, what's the derivative of cosine of x? So let's look at the rules that we just went over. The derivative of cosine of x is negative sine of x. All right, so let's go ahead and just simplify just a little bit. Again, if you're in my class, you can just leave it like this, but we'll just do some basic simplification just so it looks a little bit better. Okay, so dy dx equals secant of x times tangent of x times x cubed minus cosine of x plus secant of x plus 3 times 3x squared and then minus a negative, so that would be plus sine of x. Okay, and there we have it. That's our answer. Okay, let's do one more example. Okay, find the equation of the line tangent to y equals cosecant of x at x equals pi over 6. Okay, so what do you need for the equation of a tangent line? So when you see find the equation of a tangent line, you should think to yourself, oh, I need a point and a slope. Okay, so need a point and a slope. Okay, so we'll do each one separately. So for the point, we'll go ahead and just plug in the x value. Okay, so plug in x to find the y value. Okay, so we plug in pi over 6 into the original y, so that will be y of pi over 6 equals cosecant of pi over 6. So we reviewed the unit circle at the beginning of the school year. You should remember cosecant is the same as 1 over sine. 1 over sine. So y of pi over 6 equals 1 over sine of pi over 6. Well, what's sine of pi over 6? You should have remembered this from the unit circle, and that would be 1/2. So you have 1 over and then 1/2. 1 over 1/2 is just equivalent to 2. Okay, so our point is going to be pi over 6, comma 2. Pi over 6, comma 2. Okay, let's go ahead and find the slope. How do you find the slope? Well, you plug your x into the derivative. Well, to be able to plug it into the derivative, you need to find the derivative. So what is the derivative of y equals cosecant of x? Well, we went over that in our rules earlier. That would be negative cosecant of x cotangent of x. Okay, and so you want to plug the x into the derivative. The x was pi over 6, so we're going to find y prime of pi over 6. Which means we plug pi over 6 into both of those x's. And then we're just going to go ahead and evaluate this. Okay, so just go ahead and simplify this. Okay, so we have negative, and then cosecant, as we said earlier, was 1 over sine of pi over 6. And then cotangent of pi over 6 is going to be cosine of pi over 6 divided by sine of pi over 6. And as we said earlier, sine of pi over 6 is 1/2. So we'll go ahead and simplify those into 1/2. And so you have negative 1 over 1/2 times, and then cosine of pi over 6 is root 3 over 2. And then sine of pi over 6, of course, is 1/2. And then we'll go ahead and simplify that. And so this flips over and we get 2, so negative 2 times, and then this one simplifies to root 3. So negative 2 times root 3 is going to be the slope. Okay, this is the slope. Okay, and so now we want to write the equation of the line. And so we're going to substitute it into point slope form. If you forgot what point slope form is, that's going to be 1y minus y1 equals m times x minus x1. All right. And so m, of course, is the slope. Y1 and x1 are the x and y values of the point. And so you have y minus 2 equals, and then m, which is negative 2 root 3 times, and then x minus pi over 6. Okay, so just to reiterate, we have this is the x value. Okay, this is going to be the y value. And of course, this m is going to be the slope, which we got from plugging into the derivative. Okay, that's all. Happy day.